In this tutorial, let's look at Spring as an IOC, inversion of control container, and then how dependency injection works. Before we look at Spring, DI and IOC container details, we will first introduce you to dependency inversion principle, which is important to understand, and it is one of the 600 design principles, and how it helps us loosely couple our classes. And then we'll see how a factory pattern can be used to wire up the dependencies, and then how an IOC container like Spring replaces a factory, singleton factory class to do the dependency injection. So the first step is to go into Eclipse, click on File, New, and then we need to create a new project. So we clicked on the File, New, and the project with ellipses, that's the 3 dots next to it, and then we go Maven and say it is a new Maven project. So click on Next, and you need to provide a path. So untick the default workspace location, then go and browse, and we want to put it into the C projects folder, C projects, and say OK, and then go Next, and we're going to create a quick start Maven project, and com.mytutorial is the group ID, and here the artifact ID, let's call it learn-spring, and we can, and then go click on finish. Now you can see we got a skeleton learn spring, and here you got the source main Java, which is the Maven structure, source test Java, this is a Maven structure as well, and inside the Maven dependencies it has only brought in the JUnit 3.81 jar, and the basic package we have is com.mytutorial dot and then learn_spring as the name of the package. You can change the name if you don't like it, but we'll leave it as it is. So the next step is let's implement a naive approach where we tightly couple these classes. So you will have a Circus service, which is an implementation. So this stands for implementation. That depends on Tiger handler, which is an implementation as well. And then the Tiger handler depends on Tiger helper, which is an implementation. So this is a very naive example. Just the main key focus should be to use Eclipse and how to create those classes and understand what loose coupling is and what tight coupling is and how Spring helps loosely couple the classes. So let's go ahead and implement this naive example and with tightly coupled. So you go in here. So the tightly coupled example, first we need to define a Tiger helper. So let's go, I'm going to click on this and then press Ctrl C to copy this. So this is called the Tiger helper. So go into here, into the new Spring thing, file, right click on it, new class, and I type in Tiger helper. Click finish. And you can see now the Tiger helper inside this package com.mytutorial learn_spring. I'm going to paste the other code that we copied earlier, and that looks fine. No compiler. Let's save it. The similar way, I'm also going to now create the other classes, which are Tiger handler and the Circus service. So click on this button here, copy, Ctrl C, and this is going to be called the Tiger handler. So go in here under the same folder, file, new class, call it Tiger handler, finish, and we have created a very skeleton class. Let's copy and paste the code that was there. This link is provided at the bottom, so you can see all those classes in this particular post. And then we save this, and the next step is to create the Circus service class. So these are all implementation classes. So let's click here, Control C to copy it, go in here, same process, new class, it's called Circus service. Finish, and then I'll copy and paste this, saved. So I'll go ahead and create those. We need to create the animal handler and also the animal helper. So I'll just fast track this and I'll go and create it. So now we have gone and created those lion helper. So basically the lion helper is same as the tiger helper. The only difference is the system output line outputs lion helper instead of tiger helper, and the lion handler is very similar. Instead of using a tiger helper, the lion handler uses a lion helper. So this is all coded to implementation. So lion helper is an implementation itself, and then in the handle method, instead of printing a tiger handler, it prints a lion handler. So otherwise the lion handler and the tiger handler pretty much same. Now if we go and run, so Circus service, select on Circus service, is where the main method is. So everywhere whenever Java runs it, there's a main thread created and always looks for a main method, and this is the bootstrap. So this is where the entry point is. So if we go right click on it and say run as Java application, and it prints tiger handler in action and tiger helper in action. So what is happening here is we are creating a helper, and to the handler we are passing a helper in the constructor, because tiger handler got a constructor that takes a helper, and then we're creating a tiger service and passing the tiger service in the constructor takes a handler. So we are passing a tiger handler here, and then we are calling service.process. So this is the service class, and we have created an instance of the service, and then we are calling the process method, and the process method makes use of the tiger handler here. So it's tightly coupled to the tiger handler. So if you want to switch to the lion handler, then we have to come and change the code here and here, and then we call the handler.handle method. So it goes, because it's being a tiger handler, it's go to the handler method. So the best way to move from one to the other in Eclipse is you depress the control button, and then you go here, there will be an underline, it says open declaration, open implementation. So if you want to open the implementation, you click on open implementation. So it will easily take us to the tiger handler's handle method, and then it prints tiger handler in action. That's why we are saying here tiger handler in action. And then tiger handler is tightly coupled to the tiger helper, and also it takes a tiger helper in the constructor as an argument, and then we call it helper.help method. You press the control button again, you will see an underline open declaration, open implementation. You click on open implementation, that will take you to the tiger helper implementation, and that prints tiger helper in action. So that's why you are seeing the tiger helper in action. So the reason this is tightly coupled is because if your team lead comes and say that the tiger, we don't want to use a tiger helper with a tiger handler, now we need to switch to the lion helper implementation, because the tiger helper implementation is not adequate enough, it doesn't do enough functionalities, so we want to switch. So how do we go about doing this? The first step is in tiger handler, now we are tightly coupled to the tiger helper. So now we need to come and change this to lion helper. So we do one change here. So I change this to lion helper. So the tiger handler is used, and also we need to now change it here because the constructor has to take a lion helper instead of a tiger helper. So we change this to lion helper. So this class is okay. Now you don't get any red color squiggly bit, so there's no error anymore. Now you can see there's a red color cross here in the Circus service. Now we need to go and change the Circus service because that tiger handler doesn't take a tiger helper anymore. It has to take the lion helper. So you come and change this to lion helper. and change it here also to a lion helper. Good, so we have done all the changes. Because it's tightly coupled, we have to change it in a number of places. Now if I go right click on Circus Service and run as Java application, now see Tiger Handler in action and Lion Helper in action. So we can see a Tiger Handler is working with the Lion Helper now. And also if you have to now change the Circus Service to work with a Lion Handler instead of a Tiger Handler, now we got to go and change it here and then in the constructor here, and then also we have to change it to Lion Handler. Then you will get Lion Handler in action with Lion Helper in action. Now we'll go and see how now applying the dependency inversion principle is going to help us loosely couple the classes. So this is the bit that we have implemented now. So all tightly coupled with implementation. And now we are going to apply the dependency inversion principle, and which says the higher layers, which is a Circus Service is a higher layer because that calls a Tiger Handler, is not directly dependent on the Tiger Handler. Instead, there's an abstraction layer, which is an interface or an abstract class. That's what it depends on. And the implementation actually depends on the animal handler interface itself. So that's what the DIP pattern, object-oriented principle, states. And similarly, the Tiger Handler does not depend directly on the Tiger Helper, but on an interface called Animal Helper. And then this Tiger Helper and Lion Helper, Elephant Helper, etc. depends on the interface as well. So this is how we are loosely coupling our classes. So if we go and look at another diagram, the another way to say it is the Circus Service depends on the Animal Handler, which is an interface, and it doesn't depend directly on the lower layers implementation. And these implementation classes like Lion Handler, Tiger Handler, Elephant Handler, etc. depends on the interface, Animal Handler. And same way, the Lion Handler does not depend on Lion Helper or Tiger Helper directly, but via an interface called Animal Helper. And then let's go and implement this. So in order to implement this, we need to define this Animal Handler and Animal Helper interfaces. So Animal Helper and Animal Handler. So we go into our code here, right click on it, File, New, Interface. Instead of class, now we say interface. We're going to implement interface called Animal Helper. Finish here. And then I'm going to copy this code. Click on copy, Control C, and then I'm going to paste it here. I'm going to do the same for the Animal Handler as well. So go right click, File, New, select Interface, and this time we're going to do Animal Handler. Just finish. You can see an interface does not have an implementation method. It just defines what method it is. There's no implementation detail. So now I'm going to copy this as well, Control C, and then paste it here. And you can see this method abstract void handle by the Animal Handler is a void and abstract. There's no implementation, it's just a definition. And same way, Animal Helper will have a help method, which is an abstract void, and there's no definition at all. Now this Animal Helper interface is going to be implemented by the Lion Helper and the Tiger Helper. So I'll go to the Tiger Helper, then I say implements. So if you want to complete this, I press Control space for the code complete. Now it automatically comes and implements. Then I know that method name starts with animal helper. So I press help up to here. Then the shortcut key Control space, finish it off for me. Animal Helper. Then we have implemented this. And it's not complaining because we already have this method implemented. So if I go and comment this method, if I do Control Shift /, now its Tiger Helper is complaining, saying that you are implementing the Animal Helper interface, but you don't have a help method implemented. So here, if you hover over here, says the type tiger helper must implement the inherited abstract method animal helper help. So let's go and uncomment this. And it is also good practice to add override annotation. So I click add over and then press control space code complete, and it says add override. So basically what it is saying is we are overriding the method in the animal helper. So this override is for the abstract classes. So let's check that out, and we have got the implemented the method. So the tiger helper is an implementation of the animal helper. So it has to implement the method because animal helper has defined. So if I go and highlight this and press F3, it takes me to that class. And you can see it is an interface. It has to implement a help method. So this just defines a method signature, but no implementation is provided, just a definition. So if you go to the tiger helper, that implements it. If I change its name to say help R or something like that, it will start to complain and says it has to have a help method. So that's why you're coding to interface, and that is done. Now you go to the lion helper and do the same thing. So I click on implements IMP control space, that finish it off, and then animal HEL control space again. It asks you whether you want animal helper or animal handler. Both are IE means interfaces. I want the animal helper, and then save it. So we have implemented this. We're going to do the same for the handler. So tiger handler is going to implement control space. It's going to implement animal handler. We've got a handle method, and we also need to make another change here. This animal handler, tiger handler, should not directly depend on the lion helper because it violates the DIP principle. It has to rely on an animal helper. That means an animal helper can be a tiger helper or a lion helper. So we change this to animal helper, and also we need to change this to animal helper here as well. So both are now coded to interface. So now the tiger handler implements the animal handler interface. So in other words, tiger handler is an implementation of animal handler, and this tiger handler does not directly depend on a tiger helper or a lion helper, but on the interface, which is an animal helper, which we defined earlier, and also we are coding to interface here. So these two are the like coding to interface. Coding to interface. And also same here, we are coding basically to interface. So this implementation depends on an interface, not in an implementation directly. So save this, and then we go to the lion helper, lion handler, and need to do the same thing. So we got to extend, implements, press control space. It implements animal handler, and then we got to go and change it to use animal handler because it should depend on an interface. Animal handler is an interface, and also an interface here. Animal helper is an interface. Now we got to go to the circus service and do the same. So circus service here, depending directly on the tiger handler, because we could swap the implementation to lion handler. So we might as well depend on the animal handler here. So click on animal handler. Delete this. I've used the control space to do the code completion. Now it depends on the handler, which is an animal handler. So circus service is a higher level, higher layer, as shown here. Circus service is a higher layer, but depends, instead of on the tiger handler or a lion handler, it should depends on the animal handler. So we done it depends on the animal handler, and here also we change to depend on the animal handler. So this is coding to interface now. So everything is done. Now we go to circus service and we change it back to here. So we resume here, and instead of lion helper we call it an animal helper. Here we can assign a lion helper. So first we started with tiger helper, so let's revert back to the tiger helper. So tiger helper is assigned to animal helper, so we are according to interface here, and here also we call it an animal handler, and that creates a tiger handler. It takes a helper. So now you're going to get tiger handler in action and tiger helper in action. So we go right click on Circus Service and run as Java application, tiger handler in action and tiger helper in action. Now we want to switch the implementation to use a tiger helper with a tiger handler, lion helper with a tiger handler. So we go and change here to lion helper. So just only one change. You remember last time we had to change in a number of places. So we have changed to lion helper here, helper, and tiger handler because it's coded to interface. It can either take a lion helper or a tiger helper, so we don't have to change anything else. We save this, right click on the Circus Service and run as and say Java application. See here, tiger handler in action with tiger helper in action. So this is the power of loose coupling, because after we coded everything to interface, we only have to make very minor change to switch implementation. So we had to use lion helper instead of the tiger helper, which is good. Now we have loosely coupled it. We have used coding to interface, so we use the dependency inversion principle. Is all good. Now the Circus Service is like a client class that makes use of the animal handler and animal helper to achieve some results. But in a typical application, what if you have number of other services like sanctuary service, hunting service, wildlife service, etc. So this change that we made here to switch the implementation to lion helper, you need to go to each one of those classes. Like you will have a separate class here called sanctuary service, so you need to make the same change here. Then you will have another class called wildlife service, and then you need to make a change there. So is there a better way to further loosely couple or envisage these kind of changes? Yes, we can. So this is where the factory design pattern comes into picture. So instead of wiring up all our dependency here, because we have created a helper class and then we created the animal handler, then we are passing the helper into the animal handler, and then we are creating a new instance of the Circus Service, and then we are passing the handler into the Circus Service. So this is called the wiring up. We are creating a kind of an object graphs. So this logic can be put into a factory, so that whether you have a Circus Service or a sanctuary service or a wildlife service or whatever, they all make use of the factory. And if you have to switch implementation from tiger helper to lion helper, you just make one change in the factory, and then all the client classes like Circus Service, wildlife service and sanctuary service will automatically switch to the new wiring up. So let's look at that in this example. So we'll go and create a factory first. So what did we call the factory here? We call it an animal handler factory. So I'll copy this and then go into my Eclipse, right click on it and say file, new, class, and then I copy and paste this. It's called the animal handler factory. It's saying name is not valid because there's a space here, copy and pasting. So I'll find public, its superclass is Java lang object. So if you don't specifically extend in Java, everything extends a Java lang object. So I go and finish this here. I've got a factory here, and let me go and copy this implementation. Click on here, Control C, then go back here and then do a Control V. So let's see what the factory is doing. So factory is just building, so it is synchronized because it's a singleton class. So when you do a singleton, you do a final, so that this class cannot be extended. So any final class cannot be extended. Then you call a static animal handler. So we are going to create an instance of animal handler, and then we're going to wire up a helper. So in this case, we are using an animal helper, which is a tiger helper with a tiger handler. So we have wired it up to use tiger helper with a tiger handler, and we are synchronizing this so that if multiple threads, if two threads try to access this, only one thread can access it. and it creates an instance of it and returns that particular instance. So it's basically like a building your handler with a helper in it. This is done. Now we need to go and make use of this class. Instead of instantiating it yourself, you make use of the factory. So we need to copy this line, Control C. Then I go into my Circus service. And if you want to make it this bigger, you double click on this and this left hand side navigation go away. So you double click on it. Now I'm going to replace these two lines with the factory that I created. Just save here. Now we got a factory that knows how to build it. And whatever the handler the factory builds, I am passing to my Circus service. So I can also pass it to the wildlife service or a sanctuary service and so on. So now if I go and run the Circus service, run as Java application, says Tiger handler in action and Tiger helper in action. Now I need to switch Tiger handler to use Lion helper. So instead of changing in Circus service, I don't have to change anything because now it's further loosely coupled with the factory pattern. All I have to do is go to my factory. So here it is, where is the factory, animal handler factory. And then I go and change the implementation here. Instead of the Tiger handler to use a Tiger helper, I'm going to change this to a Lion helper. So the one change here. And then it takes a Lion helper, just put a comment in there. Then go and save it. Then I go to my Circus service, double click on again, so it minimizes it. I can see the Circus service on the right hand side. Right click on it, run as Java application. So now you see get Tiger handler in action with Lion helper. So this is where the factory pattern really shines. Now it is good, the factory pattern, but any typical commercial or non-trivial Java application will be having hundreds of those classes depending on each other. So which means you got to go and write maybe 50-60 plus factory patterns for each one of those wiring up. So this is where an IOC container like Spring comes in very handy. So Spring will allow you to wire up this externally in an XML file. So instead of using a factory pattern. So let's see now how Spring gets into action. So in detail I've mentioned what a dependency injection pattern is, what a single responsibility principle is, so you can read this, and also why we are replacing the factory pattern with the dependency injection and so on. So the first step in getting Spring introduced here is that we need to bring in the Spring context jar. So Spring context jar will depend on a lot of other jars, but we need to bring in the Spring context. So if we go to here, if we go into the central repository and I type in org Spring, so what is it called, Spring framework, is it? It's called Spring org Spring framework and Spring context. So I go back in here, Spring framework, one word, and press enter, and it gives me all the other possible Spring. See, you got a Spring agent, Spring AOP, Spring aspects, Spring bean, Spring context. So Spring context is what I'm interested in, and I'm going to bring in the version number Spring context, and the version number is 4.3.4 release version. So if I go back in here, 4.3.4 is fairly recent version, so 4.3.4 fairly recent version here, and you will see the jar file here, 4.3.4 release jar, and also you will see a POM file. So if I open a POM file, I think it depends on a lot of other Spring releases. You can see inside that it got dependencies here. It's going to bring in the JXP, it's going to bring in all these inject, JavaX money, JavaX validation, Joda time, aspect J. Is going to bring all these dependencies recursively. But as far as my project goes, I'm only interested in bringing in that Spring context, and Spring will manage, Maven will manage bringing in all the other dependencies. I copy this here, go to my POM file. So let me close all these. I go file, close all. So I will close all those and go in here. Because it's a Maven project, double click on it and it opens up the POM, which is a project object model file. This is how you define your project. So it got com my tutorial as a group ID, artifact ID is learn Spring, version is 0.01 snapshot. I say there are a number of tabs here at the bottom. I click on POM XML and double click on it. I also want to upgrade this to 4.12. The by default, the Maven archetype plugin brought in the older version. Then inside the dependencies, I go and put in the Spring dependency, Control V. Then I right click on it, source format, or I can do Control Shift F. Then I save it here. So this Maven, because this already we have looked at in the Maven and Eclipse setup projects, is Maven enabled. When bring in the Maven, because we have already set up the settings.xml file, everything through these preferences. So if I go and type here and say Maven, it knows how to go to the, so it looks at the settings.xml file from the Maven installation, and it knows how to go to this particular website here, the Maven repo, and it knows how to go and fetch this jar file. So now if I go out of here, double click on this to minimize it, and if I go into my project and click on the Maven dependencies, here we go, it has brought in all these dependencies from one. So we got JUnit, I upgraded to 4.12, and JUnit depends on Hamcrest, so we got the Hamcrest as well. Now we asked for the Spring context, so 4.3.4, it has brought in the Spring context, and this context in turn depends on Spring AOP, Spring Bean, Spring Core, because we're interested in core, comments logging, and Spring expression. So this is what called the recursive dependency management. And if I go to dependency hierarchy, and if I want to know, Spring context brought in all these dependencies, and JUnit brought in Hamcrest, and Spring context brought in all the dependencies. So now the POM file is good. Now the next step, so we go and follow as what is it in here. The first step is to define the application context.xml, where you define all the wiring up. So here the wiring up is saying we are creating a helper, in this case a lion helper, and then we're creating a handler that takes a helper in the constructor argument. So let's go into here again. Now we got to create a build path for the source main resources. So application context.xml is an XML file, so you can't put it into the source main Java, which is really for .java files. So now what I click here and I'm going to create a new build path. So I'll right click here and say right click, build path, new source folder, because we create as a source folder, so when you build it, it'll automatically go to the class path folder, which is the bin folder. So new source folder, I'm going to call it source main resources. Then I click finish and I got my source folder. Then I go right click on my source main resources, new, and I'm going to create a new other, and I'm going to create an XML file. So I've got XML and call XML file next, and I'm going to call it same the application context.xml. So Spring, normally that's a naming convention, so copy this and go in here, and that's the name of the file I'm going to create. Control V, finish. Now we got an application context.xml. This is the XML view, so I click on source again and go here, and I go and copy this, Control C and press Control V here. I got a bean.xml file. So now that we got an XML file, we need to replace the code in the customer service to use Spring XML instead of using the factory class. So here we loosely couple it with the factory. Now this code is going to change, and we go in here into this class, and we're going to call it application context. So this is where the Spring comes in handy, and we're going to copy these two lines, and then we pass it to the circus service. So that's fine. So we're going to replace this line with those two lines we copied. Press Ctrl V and save it here. Now it's saying now, oh, where's this application context? Where is this class path context? Because we haven't done any import. So there's an easier way to do it. You do Ctrl Shift O, which will do automatically import those Spring classes. So you can see this application context is a Spring class, org Spring Framework context, and also this class path XML is also from a Spring. So you go and save. It's got a yellow squiggly thing, is a warning saying potential resource leak, and it's saying it's not closed. So let's go and right click on it and say suppress warning. Not right click, so hover over here and suppress warning. Click on here, and if you want to see where this class is coming from, you click on F3, and you can see it came from the org Spring Framework context class that we have imported it, which is under Maven dependencies, and you can see Spring context here. So we'll close this again. Now we got here. So what it's saying is create a new application context, use the class path XML application context, and read the application context.xml file that we just created here, which is wiring up. So helper is just saying an ID is going to use lion helper. So okay, this is not correct, so we need to go and fix it up. So in the example that we looked it up here, I wasn't using any packages. It's a best practice to use a package. So if you look at the actual lion helper that we have used here, so if you look at the lion helper, so it's in the package com_my_tutorial learn_spring. So I go and copy this here, go into here, everything is into the package. So I got to fully qualify my class. You don't have to put the dot class, but you have to go up to lion helper. So I'm creating a lion helper. So we'll switch this to tiger helper because initially we are interested in tiger helper. And then same thing for the handler. We're using a tiger handler. It has to be fully qualified as well. So we got a package prefix. We go and put it here, copy. And to the handler, this is the constructor injection dependency. There are different types of dependency injection. You can do a setter injection and constructor injection. Normally you should prefer a constructor injection. There are areas where the setter injection might come in handy, but always favor the constructor injection. And into the tiger handler we are passing this helper reference, which is it creates, and Spring will go and create at runtime. When you start running an application, Spring will come and read this file, look at the tiger handler, it will create an instance of the helper class, tiger helper, and then it will create a handler instance of the tiger handler class and pass this helper as an argument to the constructor, because we already have a constructor method that takes helper in the tiger handler, and it wires up. And then you go in here to the circus service, you get an instance of the handler that already wired up based on what you have specified. So you take the instance of this handler reference refers to this ID here, which is a handler. This reference helper refers to this helper here. Now all we have to do is just go and run this. So right click, so we've taken the factory out and we have replaced that with the Spring as an IOC, inversion of control container. So the IOC is the container bit, and what it is doing here is doing the dependency injection in this code. So I got to go and save it. This little asterisk says it's not saved, so click on save. And also it's important to note all these things. This I means is an interface, this I means is an interface, and all the others are implementation classes. That's saved. Now we go here, right click on the circus service and then say run as Java application. Now you can see all the Spring factories is all coming from Spring Framework. Now we can see tiger helper in action and tiger handler in action, and then tiger helper in action. Now I want to switch the implementation. The tiger handler is going to use a lion helper. So I go back to my XML file here. So here we have used the tiger helper here. So I'm going to change this to lion helper. That's all I need to do. And this helper, so Spring will come in, look at the lion helper. The implementation is lion helper now, and it will create an implementation. It creates an instance of lion helper and then pass the lion helper to the tiger handler. So now you should get a different output now. So you go to the Circus service, right click on it and run as Java application. Now you can see tiger handler in action, and then it uses a lion helper in action. So I'll let you, there are quite a few things you can go and change. You can go to the Circus service, or you can create the other wild animal service, sanctuary service, and then see how you can wire up things via Spring. But it's a very simple Maven application. It's fully Mavenized, so I can go and see in the target, I can go and build it. So I can go and click run as Maven install, and it goes and automatically builds this as a Maven project, and I can run that jar and so on. So it's a fully end-to-end Java application using Eclipse, Maven, and introduces the pom.xml file where it brings in a new dependency for Spring. So you can see, and then we ask Maven to build this Java file for us. So you got the dependency here, and we were able to run. So that's all for this tutorial. Let's catch up in another tutorial.